participate. But finding that there is actually very large numbers of students online at particular points in time. So typically the very first day of the assessment, more than half of the students actually attempt the assessment on the first day that it's open. So we're still getting quite a large numbers of groups, particular assessment. What I want to do is show you a little bit about that assessment, because it will give a bit of context for where we're going, where we're taking our steps in this particular area. And so I thought I would show you through a few interfaces, and in fact, those interfaces up on screen so that you can see what they look like. So let's put a screen here. See, this is login interface for the exam, and if I log in here, let's do the same thing here. There we go. Refresh page.
You need to share your screen. We're just seeing your picture on the screen now.
Oh, sorry. The online, this is the online science assessment stage for the students as they see it. What happens is the students first have a pre-survey that they fill out, so how they feel about science, whether they study science in further years, whether they think they may make a career out of science. Some information about how within the assessment will work to understand. You can go off and start doing the test. And this is broken down into a number of sections. Each is sort of a topic that the students can access, a particular topic, and sources at the beginning. Sometimes there's audio, sometimes there's video, sometimes it's an animation or an image. And you can back those resources and then access the various questions that are inside the test. So we can go around from one to another. We can jump quickly from one area to another if we want. We don't have to do it in sequence. We can use sequence buttons, etc. And we can items as well. So that if we feel that there's an item that we want to come back to, so visually that there's an item there that's been flagged. And of course, come back to the dashboard in a sort of way. Down to another, answer particular questions on one by one. That's a very quick view of and how it works at the moment. One thing to start to explore is what we're planning to do with test into the future. So basically, the department's looking at now expanding that test into Year 6 and into Year 10. And they're very keen to look at ways in which they can bring more interactive content into the test and trial the cost of using collaborative assessment inside the test as well. So it's a really big step for us in terms of the fact that in this scenario, up to 50,000 students would be performing an online assessment, which some components of that assessment will be collaborative learning experiences. It fits very well for the science, because there is always a lot of collaborative work for students in science. So we think that's going to make a lot of sense to be able to develop some collaborative tasks to be embedded within this particular test. This is some of the changes that we're looking at that may be making to the environment. Is that alongside the traditional sections that we had in that test that I was demonstrating just a minute ago, we introduced some sections that are actually going to be collaborative sections. And then it's divided in a slightly different way, in that there will be a circle around the bottom of those particular tasks, and which is indicating how many students are actually working in that particular area. And remember, there can be thousands and thousands of students online. Potentially, there could be thousands of students together as partners on collaborative tasks whilst this particular test is running. So within the framework, we see when the students log on, parts of the test will be for a single person to do, and other parts of the test will actually be collaborative. And students will, in some ways, they have now been able to move from one section to another. They'll be able to do that, but they'll actually be able to move into a section, in fact, a collaborative section as well. So a lot of issues to be considered about this in terms of what this is going to have. One of the key questions that we're asking ourselves at the moment, with 10,000 students online, the period is how will the system be able to manage the load? With finishing various parts of the test at different times, how will students be able to be paired successfully for a collaborative task? And issues will occur if students of different skill levels are paired. So these are all very important challenges we have in particular that we're building. So the answer to the first question around having so many people online and how that achieved is being addressed by using scalable cloud services. Rather than using traditional web applications where web servers use a database and your web applications, or maybe some very large web servers, we've created horizontal scalable servers that allows you to have hundreds of web roles running at the same time to be able to support the numbers of users that we're expecting. So instead of using traditional SQL databases, we're using what we call scalable storage. It's often referred to as NoSQL databases, which need to be able to store many more transactions on a regular basis than a normal SQL database. And it's able to scale and increase its capacity as more users come online. And as I said, there are some background worker processes that need to be in place to support this environment. So our current estimate is that we will have about 800 small web servers environment when we run the test later on this year to be able to support all functionality that's going to be provided both for students answering the questions in the traditional test, for the students being able to participate collaboratively together to form the collaborative items as well. So we anticipate that we could see up to 10,000 students online at any one particular point in time. What we believe is that I know at the moment is that when we've got 10,000 students online, that there's an average of around 10,000 answers stored each minute. In other words, students tend to answer a multiple choice question one minute, or so we're generating that many numbers of answers every minute. Now, having a student answer does create a certain number of transactions back on servers. In fact, it translates to about 6 transactions for the answer that's stored. So there's actually about 1,000 data transactions taking place in the system when we have 10,000 users online. which is quite a significant number of data transactions, and that a normal SQL databases will be difficult to be able to support for any period of time. Once we move to a collaborative model, and the students are working collaboratively on tasks, the amount of information that's being exchanged increases quite dramatically, because the information no longer is information being transmitted. When the student finishes the question, it's constant information that's being transmitted between the two students who are working together, and all of that information that is shared between those two students, much of that needs to be recorded. All of it needs to be able to be communicated and passed backwards and forwards between two students. When we've got students collaborating together, we're creating more than 10,000 messages each second, and with something like 10,000 simultaneous server connections. It's really got a massive increase in the server usage that we're expecting when we implement the collaborative tasks in exam later year. A lot of work being done at the moment in terms of the design for the extensions to the system are going to be able to scale, to be able to across the environment that we're building, the cloud server environment that we're building for this particular assessment. So just a bit of background. Previous events for this particular test, we've recorded quite a lot of information about those events and how those events have unfolded. Here's a snapshot from an event at about 10 o'clock in the morning, and this was in a particular time when we had all of the students doing the event in the one day. Here is there are 10,000 students online at this point in time. There's 500 schools online. This is running at about 12% CPU, 142 being stored systems second during time. There's quite a lot of activity going on from a server perspective. This previous example of an event. So we're expecting to see 5 to 10 times this amount of activity with a new collaborative task being embedded into the ESSER assessment event. So we're looking at a number of ways in which we might be able to provide better ways in which the students prepare to do the event. When we've worked with ATC 21 team, we set the pairings of students. In other words, students were grouped together into classes, but the actual pairings were also pre-created in the system. We knew which students were going to be working with which student before the actual students logged on. This test, what we're planning is a quite different approach. We're planning to allow the students to pair in an ad hoc process. It's when students click on the collaborative task, they will just simply be linked up to another student who's clicking on that task at roughly the same time. And if there are no students, they will wait until another student clicks on the. Our plans are that we will have two collaborative tasks in the new ESSER test. So in the task, our plan is that we'll have an ad hoc pairing, which will typically pair any students. There'll be no filtering whatsoever for that particular task. And in the other task, we need to pair students who've achieved similar results in various parts of the test. For many parts of the test, the questions that students answer the answers can be automatically marked, and they are automatically marked as the students record results. So we will have an idea as to students are in which percentiles for this before they click on the collaborative component of the test. And we'll make the collaborative component of the test unavailable until students have completed a certain proportion of the landed questions before getting into the collaborative component. So it's to have actually one task where we really don't have any control over what type of students work together, although we'll know after the event what also each of those students had. And then a task, we'll make a process where we actually pair students who've got similar results. And it will be interesting to see from that perspective what change levels of accomplishment in terms of collaboration are achieved between those two different types of pairings that we provide. To give an example, this is a bit of a mock-up of an idea for a test that we've been putting together. Now, this has been based on one of the AC21S questions. It's based on a question called plant growth. We don't think that we'll actually be using this question in the final test. We'll be developing our own tasks for this particular area. But it's been informing us in some of the ideas that we're having around the task and the types of tools, etc., that we're going to provide. In ATC 21, what we saw was that students were often presented with tasks that were not easy to understand. In other words, there was very little scaffolding for the students to understand what their task was and how they would go about doing that particular task. In our implementation, we want to give students a little bit more information about what to do, how they'll be working together, some that might even explain how to use some of the tools before they reach the environment. We believe that certainly in the initial case, the student needs a little bit more information before they get dropped into being able to work collaboratively with one of these tasks. So it'd actually be a good idea at this point to show you what plant growth looks like in the AC21 environment, and then come back and talk a little bit more about the changes and the approach that we're taking with this particular environment. So just pull that down for a minute. Got two on my display. We log on as one student this web browser, and we'll log in as another student over here. Pick the playlist. Another feature of the ATC 21 task is that you, as a student, you get to pick which role that you wish to be. We probably won't be doing this in our implementation for ESSA as well. We'll have those roles randomly allocated to the students when they enter the task. So they won't see this type of screen. This is a little bit confusing because we're pretending to be two people at the same time, but that's a rough idea of how it all works. So this is student A and student B. The student A, the interface looks almost exactly the same. There's differences, however. In this machine, I'm able to move temperature control. I'm able to move the lighting control. Over here, I can't move the lighting temperature control. I move the lighting control. Notice that what's actually happening is that as I move control on this particular browser, the control, once I release it, the control is moving on over here. So what I do over here is being communicated back to this machine over on the side. Also, the question that the students have to answer slightly different to each machine. You'll note that on this one we say, now complete the following rule about how the light affects growth. And I say, now complete the following rule about how the temperature affects growth. So you have to do slightly different activities to answer both of these questions, which is basically try out the settings to be able to work out when that we can make the growth of the plant. As when as plants grow, where the plants grow, there's the same or more or less it gets too hot or just right or too cold. So we have to understand whether there's some further information in there to be able to answer that question as well. How the ATC 21 task was implemented. So I'm going back to these slides for a minute. For the test, we plan to do something quite similar. We're also to make sure that we do all of the collaborative work within the task, that we'll be marking that collaborative process as the task activity. In other words, the task itself will be monitoring how well the students work together and recording that information into the back end of the system. So all the collaborative effort that the two students perform will be measured by the task and recorded into the assessment system as students are performing the actual activity. We believe that there is going to be a need for some other capabilities for the students in terms of they can work together within the task, and what might happen if one of the students isn't able to work effectively with the other student. So the roles and that we're setting in this particular environment for in 2014. So we have the first collaborative task in ESSA for 2014. Our team is starting to on the task development this month with the team themselves, and we'll start trialling some of those tasks in some of our trial processes that will take place before the final assessment in November. With the plant growth example as a trial, as a guide, but we also think that we will be developing different new tasks to align to the current test topics for this year. And we're seeing the Year 8 test for students, so students who are approximately 14 years of age. the tasks where ATC 21 tasks were record log file of activity. We'll be still recording a log file of activity, but we'll be automatically marking and measuring the student collaboration as we go. So rather than the log file being a way to mark the task, the log will become a way for students to analyse how students performed in tasks, but the tasks themselves will actually provide the mark, collaboration and the answers. We plan to allow the students more freedom to navigate between segments of the task. Previously, in the ATC task, some student wasn't able to move from one part of the question to another part of the question without the agreement of the student. That needs to be loosened a little bit, allow and provide more freedom to allow the students to move between one segment of the task to the other segment of the task, and that the navigation between the segments of the task is something that could be recorded as an element of the collaboration between the two students. Also be explaining more detail how to do that and how to monitor where each student is. Now, when one student is in one section of the task and another student is in another section of the task, there'll be visual indications to both students as to what is happening, and they'll be able to navigate to be able to be in the same part of the system at the same time. We believe that we need to be able to provide an ability for students to be able to abandon partnerships under certain conditions. So what we did from that we did in ATC 21 was that often many failed partnerships, and the reasons for that is that we've got a situation where one student's not going to be able to work effectively with a student. So we want to provide a certain processes that will allow students to abandon a partnership and to then re-establish a new partnership with somebody else. I think this is able to be provided effectively through the ability to be able to establish the ad hoc partnerships through the task selection that we're putting together. Finally, once all of that's been put in place, we'll pilot the tasks part of the formal test in November with over 6,000 students. So that's my slides for today. I hope you found that interesting. I'm sure we're looking to answering any questions that you might have about what we're working on with Wales and what we're planning to provide. Just back over to Krosh. Are there any questions at this particular point in time?
Fascinating, Wayne. Thanks very much. I wonder if the task, the manipulation of variables task, can be gained by the students once they learn that they simply need to take turns and in a systematic way manipulate A, B. Any thought given to that, whether you can gain the collaboration in a highly structured task?
I think there's not enough thought into that at the moment, Scott. It's going to come out in some of the task design that we had in the past, where we've looked at how the students have gone about these tasks. Some students have found them easier than others, so there's a real variety in the levels of performance of the particular task. So I think one of the real challenges is being able to provide tasks that will be able to really across a wide group of students.
I agree with you, and just wonder if you get more open-ended tasks or less structured tasks, you aren't going to get a greater variety of responses. But I wonder then if it gets harder to score and evaluate the operation automatically.
One of the advantages of having a task with such closed process is that you develop inside the task metrics or key markers that actually indicate that the students have effectively worked together to perform a particular function, and that's one of the tricks to the task development that we're to implement. So by having a structured set of markers within the task that record the two students have had to work in a collaborative fashion to be able to achieve a certain element of the task, will be able to indicate students have performed to a degree a collaborative activity.
Right. Thank you.
Okay.
Crush. Okay, so now we have a question from Margaret, and her question is, what if the question is not demanding collaboration to get the answer? A student knows already the effect of temperature, brightness on plant growth.
That's a good question, isn't it? Well, I think the students would be able to answer the question, and therefore, and if to get the question right, has only one element of the task. So the task would be how the students to hypothesis into the effect of temperature and brightness on plant growth. So if the task didn't see the two students testing the various options, forming a plan and a hypothesis for what an approach to how to do that task, then when they have the answer correct, there'll be no information recorded about how they've worked collaboratively together.
Question from Martin. How much of an issue is local bandwidth and quality of kit in schools?
That's a question too, Martin. The experience that we have so far is that there are some issues with quality of kit in schools, but tasks are built in HTML5. So they require any extra software to be installed on a person's computer. They do require either the browser that the students are using, the HTML5 compatible web browser. So that means that they can't really use an IE7 or an IE6 or an IE8. It must be at least IE9 or Safari 6 or a fairly recent version of Chrome or Firefox. So any browser that's older than the minimum levels for HTML5 compliance, these tasks will not in. So they just simply will not run. Because using HTML5, the amount of bandwidth that's required is very, very small. So these tasks, the interfaces that we've been developing, don't use up very much bandwidth at all. But the information that's being transmitted between the web pages and the web server is quite minute as well. And that's being transmitted by something called WebSockets, which is part of the HTML5 standard as well. So very, very small.
Okay. Pat is asking, how do you score these tasks? Is it overall performance score only? And report out, and to whom are score reports given?
Sorry, the question. Well, at the moment, some of this is decided. We haven't developed the new tasks and the scoring algorithms. We should have two classes of score. One will be the score of the actual performance of finding the answer, but the second score will be assessed against a framework that examines the way that the students have collaborated together. So we've been looking at the framework that the AC21 team put on, and are looking at ways in which we can implement that within the system. In other words, the task will be able to work against a number of different areas students have worked effectively together. So the answer is it won't be one simple score for these tasks. There'll be a score in terms of how well what the answers the students derive from in the task, but there will also be a score against a collaborative framework to indicate to all did the students collaborate across a whole range of areas during the task. And so those reports will be provided back to the teachers and to the parents. At the moment, the assessment, all the other questions are scored and marked, and a very detailed report is given back to teachers and to parents around their students' performance. Haven't quite, with the department, we haven't worked out exactly what we're going to do with the collaborative tasks in this particular year. We believe at the moment we will just be using these tasks as a trial, and we won't be reporting the results for a particular year until we see how effective they work inside the environment.
Great. We have a question from Ben Murray. Have you thought what metrics / rubrics might be labeled as to get information in Google format to the students or teachers?
I haven't actually thought in too much detail about that yet. Perhaps referring again to the collaborative framework, we've been looking at the ATC framework, and we'll be working with the South Wales team and the Island team as well in issuing a framework that they're comfortable with into those metrics. And we've got those rubrics established to in the task, the process for being able to map the assessment activities against those rubrics.
Okay. Margaret is asking, might need to have more explicit information that collaboration and strategy / problem solving is being assessed and is not the answer provided, and how is the feedback obtained for students, what their next steps in collaborative learning might be for them to progress.
So, yes, it's true that the students need more information about this process. And in the last one, some of the things that we've done with this particular online test is provided readiness tests that actually give students a practice environment before they actually perform the formal test. So part of our planning here is to have a collaborative task as part of the readiness test. So there'll be an opportunity for the students to learn on a collaborative task before the actual formal assessment. So hopefully that will help them become more familiar with what they'll experience within the actual formal exam. Turning back to the students, I think that's going to be up to the task design and our teachers and designers feel about what they want to be able to feed back to the students. As the technology developers, we don't really have a in that, but I would think that there'll be quite a thinking going into the type of feedback that's provided back to students whilst performing the task.
I think we have time for a couple more questions. If you have any questions, please feel free to ask it in the chat box.
So maybe we're out of questions.
Maybe we're good.
Yeah, maybe good. Let me the webinar today, and firstly, if we could just progress. Thank you very much. First, to thank Wayne for what I thought was a very interesting webinar presentation, and particularly in the thing that's already gone around how we might deploy the new types of investments embedded in more established assessment methodologies. And of course, when we do so, that opens up questions, and that's one of the purposes of the Collaborative Assessment Alliance, is that we can forum where we can discuss these issues and get more ready and contribute collective, I guess, to trying to work out exactly how we can go ahead. I think it's very exciting when you start to look at something like the ESSA test that's been done now for 5 years, and then how we can integrate these new forms of assessment within that existing mechanism. Of course, that's the only way, and we hope that there'll be lots of new thinking applied on that as we move forward. So thanks again, Wayne, for the webinar. Thanks, everyone, for the questions you asked. I quite enjoyed the discussion. I think it was a really good discussion. I'd like to wind up today by thanking our founding partners who have contributed to the work that we're doing, and that includes Cambridge University Press, TS, Intel, Microsoft, Janison, and Collaborative Impact. And I'd like to remind you that there is follow-up to this webinar. The webinar has been recorded, so we can share it with you, and we'll provide a link to delegates, and please share it within your organisations and beyond your organisations. We will be posting it on YouTube as well, so that you can have a link if you want to share order using that form. We'll follow up with an email so that you have that information, as well as other information about collaborative assessment. And if you do want to learn more about the Collaborative Assessment Alliance, please, you can contact me, or you can go to our website, and the URL is there, to find out more information. So thanks again, everyone. Appreciate you taking the time, and Wayne, and we look forward to you for our next webinar. We'll see out information about shortly. Take care. Have a good day.